This lecture video is about solving radical equations, and so all of these equations will have a square root in them. Our first example is square root of x plus 1 equals 7, and so we need to undo that square root, and if you remember, squaring is what will undo a square root. And so we're going to square both sides of this equation. So whatever you do to one side of an equation, remember you have to do to the other. And this square root and this square basically cancel each other out, so this will just be x plus 1. And 7 squared is 49. And then subtract 1 from both sides of the equation, and you get x is equal to 47. Sorry, 48. So this is one type of equation that you'll always need to check your solution on. Occasionally the solutions won't work, and it happens because you're squaring both sides of the equation. You can end up with some extra solutions sometimes then. So this one's going to work out just fine. If I plug 48 in for x, I get the square root of 48 plus 1 is equal to, and I always put a question mark over my equal sign when I'm checking an equation. And so that's equal to 7, and we get the square root of 49 equals 7, and you can stop as soon as you know it's true, and I put a big capital T there to let myself know that it worked. Our next equation is the square root of 3x is equal to negative 6, and this one actually has no solutions. Remember, square roots are always positive, so whenever you have a square root equal a negative number, there will not be any solutions. If you don't happen to catch that, though, you go ahead and solve it. You would square both sides. And so we get the square root of 3x squared, which gives us just 3x. And then negative 6 squared is a positive 36. And then we divide by 3 on both sides, giving us x equals 12. And when we go to check our solution, then we get the square root of 3 times 12 equals negative 6. And again, I always put my question mark there. You don't need to, but it's something I always do. And so we get the square root of 36 equals negative 6, which is false. And so that would lead you to the conclusion that there is no solution. Our next example here, we have the square root of 5x plus 6. And then plus 2 outside of the square root is equal to 8. You need to have this square root by itself before you can square both sides. So the first thing I need to do is subtract this 2 from both sides. That gives me square root of 5x plus 6 is equal to 6. And then we would square both sides at this point. And the square root and the square cancel each other out, so we get 5x plus 6 is equal to 6 squared, which is 36. And to finish solving, we subtract 6 from both sides. We get 5x is equal to 30. And then divide by 5. And that gives us x equals 6. Check your solution quick. So we get the square root of 5 times 6 plus 6. And then plus 2, is this equal to 8? And 5 times 6 is 30, plus 6 gives us 36, so that's the square root of 36, plus 2, and yes, that is equal to 8. We get 6 plus 2. And again, you can stop as soon as you know that it's true for sure. Our next example, square root of 4x plus 1 equals 3, plus the square root of x minus 2. So this one has 2 square roots. And when you have 2 square roots, we're going to need to square both sides of the equation, and we're going to end up having to do it twice. So I'm just going to do it up here. And when we square this side, because it just has the square root by itself, it's just the square root and the square will cancel each other out, so you get 4x plus 1. Here, when you square this side, you need to remember to do FOIL, because it's this whole quantity times itself. So we have 3 plus the square root of x minus 2 times the quantity 3 plus the square root of x minus 2. And so you need to remember to do FOIL. Okay, so when we do FOIL, we're going to get 3 times 3, which is 9, and 3 times the square root of x minus 2. And here we'll get another 3 times the square root of x minus 2. And then the square root of x minus 2 times the square root of x minus 2 is just going to be plus x minus 2. So we have 4x plus 1, and we have 9 and negative 2, so that's 7. And we also have this x here, so we have x plus 7. We have 3 square root of x minus 2's here, and another 3 here, so that's plus 6 times the square root of x minus 2. Now we want to get this square root by itself, and so we were going to move the x and the 7 over. So I'm going to subtract x and also subtract 7. So 4x minus x is 3x, and 1 minus 7 is negative 6. So on the left we have 3x minus 6, and over here we have 6 times the square root of x minus 2. Usually we get this square root completely by itself, but when this number that you have in front of the square root doesn't evenly divide both of these, then I just leave it right there, because if I divide both sides by 6, I'll end up with a fraction. I'll end up with 1/2 x, and I don't want that, so I'm just going to leave the 6 there for now. So now I need to square both sides again, so I'll just do that in red. And so here you have to remember to do FOIL, because you have 3x minus 6 times 3x minus 6. And over here you have to remember to square the 6 and the square root of x minus 2. 6 squared is 36. And then don't forget to keep this in parentheses. Okay. So now here we have to do FOIL. 3x times 3x is 9x squared. 3x times negative 6 is negative 18x. Negative 6 times 3x is another negative 18x. And negative 6 times negative 6 is positive 36. And then you can distribute this 36, giving you 36x minus 72. Now we want to gather up like terms. So we have 9x squared minus 36x plus 36 equals 36x minus 72. So this is a quadratic, and when you're solving quadratics you need to have 0 on one side, so I'm going to subtract the 36x and add the 72. And you always want to keep your x squared positive. And when we do that, we end up with 9x squared and minus 72x. And then here we have 108. All of these terms are divisible by 9, so you want to go ahead and do that. It will make your factoring a lot easier. Okay, 9x squared divided by 9 is x squared. And we can think about, we're really dividing everything by 9, but 0 divided by anything is just 0. And 72 divided by 9, so that's going to be negative 8x. And then 108 divided by 9 gives us 12. And again, 0 divided by 9 is 0. So now, go ahead and factor this. This will factor as x minus 2 times x minus 6. So you want to factor 12 so that the sum will give you negative 8. So that's negative 2 and negative 6. They multiply to give me positive 12 and add together to give me negative 8. Then set each of your factors equal to 0. So x minus 2 equals 0 gives me x equals 2. And x minus 6 equals 0 gives me x equals 6. Again, you need to make sure that you check both of these solutions. So plug 2 back up into our original equation. So that's the square root of 4 times 2 plus 1. So is this equal to 3 plus the square root of 2 minus 2? And here we get 8 square root of 9 is equal to, and this is the square root of 0, which is just 0. And so that one does work. And then we also need to check 6. So square root of 4 times 6 plus 1. Is this equal to 3 plus the square root of 6 minus 2? So here we get the square root of 25, which is 5. And here we have 3 plus, this is the square root of 4, which is 2, and so that one also works. So both of them work this time, but again, they don't always, so you have to make sure that you do that check. Our next example, square root of x plus 20 minus the square root of x minus 4 equals 4. When you're solving equations that have two square roots, you want one square root on both sides, and you want one of the square roots to be by itself. So I'm going to add this square root of x minus 4 to both sides. That gives us the square root of x plus 20 equals 4 plus the square root of x minus 4. And it's my preference when I'm adding things on the same side of an equation with a square root to have it in front. So I always like to have this 4 in front instead of back here. It just helps me remember that it's not underneath the square root. It's just easier to tell that way. Okay, so now we're going to square both sides. And when we square the left-hand side, the square and the square root cancel each other out, so we're left with x plus 20. Here you have to remember to do FOIL. I oftentimes will just write my second term down alongside. And so 4 times 4 is 16. And 4 times the square root of x minus 4 is plus 4 times the square root of x minus 4. And then we get another plus 4 times the square root of x minus 4. And then the square root of x minus 4 times the square root of x minus 4 is plus x minus 4. So we have x plus 20. We have an x and a 16 and a negative 4, so that's plus 12. And then we have plus 8 times the square root of x minus 4. Now we want to gather up all of our terms except for this square root over on the left over here. So we're going to subtract 12 and subtract x. And so x minus x is 0, and 20 minus 12 is 8. So we get 8 is equal to 8 times the square root of x minus 4. So now in this situation, I'm going to divide both sides by 8. So these 8s will cancel, and I'll just be left with 1 equals the square root of x minus 4. You don't need to do that. You'll still end up with the correct answer if you don't. This just makes your numbers a little bit smaller. So now I have a single square root by itself, and so I'm going to have to square both sides again to get rid of that square root. 1 squared is 1, and the square root and the squaring cancel each other out, so I'm left with x minus 4, and then we add 4 to both sides, giving me x equals 5. So before I put my square around it, I just want to check to make sure that that really works. So that'd be the square root of 5 plus 20 minus the square root of 5 minus 4. Does this end up giving us 4? And so this is the square root of 25, which is 5. This is the square root of 1, which is 1. And 5 minus 1 actually is 4. So the solution that we got does work. So at that point is when I would put my box around it. Our next example here, again, two square roots. We have the square root of x plus 3 equals the square root of x plus 21. So we have one square root on both sides, so we're at the point where we can square both sides of this equation. And over here, remember, you have to remember to do FOIL. So square root of x times the square root of x is x. Square root of x times 3 is plus 3 square root of x. Then we get another plus 3 square root of x, and plus 9. And over here we get x plus 21. Simplify this side, so these two terms we can combine. So we get x plus 6 times the square root of x plus 9 equals x plus 21. We want to get this square root by itself, so we need to subtract the x and subtract the 9 from both sides. So these x's then are gone, and so is the 9, so we're left with 6 times the square root of x. And x minus x is 0, and 21 minus 9 gives us 12. So again, the 12 is divisible by the 6, so I'm going to go ahead and divide by the 6, giving me the square root of x equals 2, and then we can square both sides again to get rid of that last square root. That gives us x is equal to 4. So now I'm going to go ahead and check to make sure that that solution works. Square root of 4 plus 3. Is this really equal to the square root of 4 plus 21? So this is 2 plus 3, which is 5. And here we have the square root of 25, which is also 5. And so that solution works. In our next example here, we just have two single square roots that are equal to each other. So we're going to go ahead and square both sides of this. And that cancels out all of our square roots. And we end up with 4x minus 3 is equal to x plus 6. So now I want to get the x's on one side. So subtract x from both sides. We get 3x minus 3 equals 6. Add the 3 to both sides. Gives us 3x equals 9. And last step is to divide by 3. Gives us x equals 3. Do the little check. Square root of 4 times 3 minus 3. So is this going to be equal to the square root of 3 plus 6? So here we have 12 minus 3 is 9. So we get 3, and here we have the square root of 9 as well, so that's also 3. And our last example, square root of x plus 1 minus the square root of x minus 1 equals 2. So we're going to add this square root to get one square root on both sides of the equation. We get the square root of x plus 1 equals 2 plus the square root of x minus 1. And then we square both sides. We get x plus 1, and here remember to do FOIL. 2 times 2 is 4, and then plus 2 square root of x minus 1. And then we'll get another 2 times the square root of x minus 1, and then plus x minus 1. So we have x plus 1 equals, we have an x, and then we have 4 minus 1 is 3, and then we have plus 4 times the square root of x minus 1. Now we need to get this squared alone, so we're going to subtract x from both sides and also subtract 3. And so here we get 0, and 1 minus 3 is negative 2. And so we do have a negative 2 here, and so we should end up with no solution. But we're going to go ahead and square both sides and solve it anyways. And negative 2 squared is 4. And then remember to square the 4, giving you 16. And then when you square the square root of x minus 1, we get x minus 1. So we have 4 is equal to 16x minus 16. And we want to add 16 to both sides. And so we get 16x is equal to 20, and then divide by 16. And that gives us x is equal to this. We can simplify. Both 20 and 16 are divisible by 4, so we get 5/4. And so again, we need to check that solution. and we get the square root of 5/4 plus 1 minus the square root of 5/4 minus 1. Is this equal to 2? And it should not work. So 5/4 plus 1 is the same as 4/4, so that would be the square root of 9/4 minus, again, 1 is 4/4, so that would be the square root of 1/4. And so this square root of 9/4 is 3/2, and the square root of 1/4 is 1/2. And 3/2 minus 1/2 gives you 2/2, which is 1. So we end up with no solution. Again, you could have stopped right here as soon as you saw that you had a square root was equal to something negative and said no solution at that point. Let me know if you have any questions about anything, and I hope all is going well. Thanks.